So this question is actually quite difficult. It took me quite some time to actually understand this. Part A isn't quite difficult, but part B, I'm sure that definitely won't come on any of your tests or anything. So yeah, I'll try my best to explain this, or the best I understood how to solve part B. But part A is quite simple. So it's asking for the work, and so work is always equal to the gravitational potential energy. And so let's say we had boxes. We had these three boxes stacked up here, and you want to put this one box all the way up here. How would you model the gravitational potential energy? Well, to do so, we know that the gravitational potential energy is equal to the mass into gravity into the height. So what is the height this box would have to travel? Well, the height the box would have to travel would be of two boxes. This is one box, and this is two boxes. And there are a total of three boxes over here. So we could say that if n represents 3 in this case, then this box would have to travel n minus 1. Because remember, I said this box has to travel 2 boxes worth of height, and there are a total of 3 boxes stacked. And so what we can do is for any stack of boxes that are vertical, if you were to add another box, and that specific box would have to travel n minus 1 height of all the vertical stacked boxes. So that's part A. Part B is where it gets a little bit more tricky. And so in part B, what it's asking for is the gravitational potential energy stored in the entire pile. And so again, we know the gravitational potential energy is equal to mass into gravity into change in y. And so again, if we do have a bunch of boxes, what it's going to look like will be, if we were to calculate the sum of all the boxes, if you were to sort of figure out what the height should be, it's going to look like this. So if we have mg, then you have change in y, and then from there you have to do 1 plus 2 plus 3 plus 4, and then you have to keep on going until you reach n. And so there's a specific way of writing a sequence like this, and it looks a little something like this. It's okay if you don't know it, because I'll guarantee you I did not know this until I sort of had to Google search and learn it myself. But you have this sum. On top of the sum, you have an n, kind of like this, with I representing the amount of times you're sort of adding boxes. And then there's a well-known equation for something like this, and that would be n plus 1 divided by 2. But in this case, remember, it has to be n minus 1. Just like we explained over here, these boxes have to travel n minus 1 distance upwards. So if you were to model the gravitational potential energy, it would be mass into gravity into the change of height, which is then going to be this right here, just copied down like this. I'm sure I didn't explain part B too well, but I doubt it will come on any of your tests.